Thank you. So one of the things I put in is a teacher's desk. Now, the front of the room is actually right here. And so you'll notice the teacher's desk is more towards the back of the room, or off to the side of the room. Now, you'll also notice that these boxes that have the littler squares, those are groups of student desks. And so rather than sitting in rows that you've shown, and rows that you've shown, teachers often have students sitting together in a group. And so they can work on assignments in small groups. You'll also notice I only put 24 students in this classroom. And I noticed, one for you said, how many students do you have?
In classroom, 35
to 38. So you have a lot more students in your classrooms. Sometimes in the United States, we will see bigger class sizes. The school that I work in, the class size is closer to 24, 25, especially for, say, kindergarten, first grade, second grade. But I would say one of the differences that, when you were describing Thailand schools, and what I've seen here would be a smaller class size. And this idea of having students grouped together to work together. This is supposed to be a rug for students to sit when they're doing reading, so they can sit and have some space to read. This is what they call a kidney table. I don't know if you've ever seen a kidney table, but it's shaped so that students can sit around the edge, and the teacher can sit in this kind of cutout area and look at all the teachers, or the teacher has a chance to kind of work with all the students at the same time. So a lot of classrooms have those. I put some bookshelves in. This is supposed to be a smart board or a projector. We're seeing a lot of those in our classrooms. And one of the reasons that this particular setup for a classroom works well for science is because even at the early grades, we like to do what we call inquiry-oriented science. And I believe Dr. Crawford talked with you about inquiry a couple of days ago, or last week. So what I wanted to do was to talk about inquiry in elementary classrooms. It's one of the, that is a direction that science educators are encouraged, or they're encouraged to use inquiry with young kids. So based on current research, we think that young students are quite capable of doing inquiry. But as a teacher, you really need to know how to support those aspects of inquiry. So I'm going to first talk about some of the tenets of inquiry and the ones that I highlight for my students. And then we're actually going to do our own investigation and kind of talk about how the elements of inquiry work in that investigation. And then I have a video that's of a U.S. classroom of a teacher using inquiry with her students. So we'll talk about inquiry, we'll do our own investigation to talk about aspects of inquiry, and then we're going to watch an example of what it might look like in a classroom. So thank you so much for holding up my... Okay, let's see if I can... Let's see, we already talked about that. Okay. So as I mentioned, for young children, and in the United States, elementary school is grades kindergarten through 5. So in kindergarten, students are about 5 years old, and then 5th grade, they're roughly 10 years old. So that's the time we're looking at. I try to get my pre-service teachers or prospective teachers to use inquiry-oriented instruction. When I talk to them about inquiry, I use a version of inquiry where they're looking at asking investigable questions, where you're getting students to collect evidence to help you answer a question. You're getting students to generate an explanation based on the evidence they collected. You're trying to help students connect with other scientific information, and then getting them to justify claims and evidence. So if you look at some of the national documents about science inquiry, these are often 5 essential features of inquiry. And I can absolutely give you references to where to find more information about these. And NRC, yeah. But in terms of asking an investigable question, okay. So we can have students ask any kind of question that they want. You could have a student ask the question, why am I happy today? But is that a question they can actually gather evidence to answer? That gets to be harder. So when we talk about science, we try to get them to ask questions that they can investigate, and that those investigations can help them answer. I use a methods book that's written by John Settlage and Sherry Sutherland, and the way they talk about it, they say an investigable question is a question that a student can try to answer through the use of scientific thinking. I messed that up. Let me start over again. A question that a student can try to answer through the use of scientific thinking is termed an investigable question. An investigable question that is well formulated will suggest how one could go about finding an answer. And so, in terms of getting students used to doing inquiry, you want them to start learning how to ask questions. But with science, science is about the natural world. Science doesn't answer all the questions ever asked, but we're limited to questions that can be answered using evidence. So especially with young children, getting them to learn how to ask a scientific question. And again, what I like is, in here they say, a question that is well formulated will suggest how one would go about finding an answer. Because we want students to learn how to answer these questions. Okay. Students can learn to answer questions by gathering evidence. So the evidence that is gathered must address the question being asked. At its most basic, the analysis of data simply requires that the observations or measurements be organized in some way that one can see if any patterns exist. And how many people in here teach science? I know we have science and we have math. Okay. And so think about if you were going to do an investigation, you have to come up with the right kind of data to help you answer or come up with an explanation. And for your students, it's very important to get them to think about, if I'm trying to ask a question about, let's say, what affects the biodiversity outside my school, or what affects the habitat outside my school, they'd have to be able to collect evidence to help answer that question. And that's not, when you're talking about working with really young students, that's not a necessarily easy thing to do, but they're very capable of doing it. And once students have gathered evidence, then they have to develop an explanation. Or doing inquiry involves developing an explanation from the evidence you've gathered. So the process of making sense of data and proposing explanations for evidence is a vital skill within the culture of science. And I would say for young students, this is really, really difficult, but incredibly rewarding. Students love science. They especially love science when they get to do something. But for the teacher, it's a very, very demanding practice. Because as the teacher, you are trying to think about the ideas you want them to learn, the content you want them to learn. You're also trying to figure out, if I'm trying to get them to learn about, let's use habitats again, and you want them to investigate habitats, you have to come up with the right investigation that's going to help them see the relevant variables. Because if you have them investigate, say, marshmallows, when you want them to learn about habitats, there's not much in there about habitats. And that's where it gets to be difficult. Because as the teacher, it does take a lot of thinking on your part about what investigation do I select? What materials do I give my students to help them understand this? And then how do I help them make sense of something? So if anybody has worked with young students doing science, they like science, don't they? Yeah, and it's difficult to get.
Yes, sometimes students have many questions, but they don't know what topic related about the question. This question is difficult.
Yeah.
The teacher must support what topic is related.
Mm-hmm. Absolutely. And I find, I mean, as the teacher, you have to have a fair amount of content, so know enough of the science to know how to answer students' questions. And that can be hard too, just because you have to know enough to answer their questions and then to figure out what different misconceptions they might have. Is misconception a word that's familiar?
Yes.
Okay. Oh, okay, yeah, so, and students often come to elementary school with several science misconceptions.
Okay.
But if you have to think about the logic of their thinking. I have my students, they are kind of interviewing students in their classroom about day and night and seasons and phases of the moon. Because I can tell them, your kindergarten students have really interesting ideas about what happens to the moon during the day. They have different misconceptions about where the moon goes or where the stars go. And I can say that to them, but it's much more compelling or interesting when they hear it from their students. So they come back and they say, my student said the moon gets covered up by clouds, and that's why we can't see it. Or that or they'll say something like that, and I have this conversation with them about, yeah, students have really interesting ideas about science. And to us as adults, they may not make sense. But think about it from the perspective of your student. You have to start seeing some of the logic of their thinking. If you've never learned that the moon and the earth and the sun kind of move around in this space, you've never thought about why you're going to see the moon look different. It may be very intuitive that clouds covered and that's why I can't see it. And so that's why you have to pay a lot of attention to what your students say, because you're using that information to then guide your instruction. And I think that's the part that gets to be really difficult. But in terms of helping students generate explanations, as the teacher, you're trying to get them to take in the information they've gathered and kind of coordinate that with their own thinking to help them develop explanations. And they're very capable of doing it. As a teacher, it takes a lot of thinking about putting the right pieces in place. Okay, so I promised we would do our own investigation. We are going to investigate, and maybe you've done this before and you already know the answer, but let's pretend yes.
Will you continue with the next two elaborate
I wasn't going to. I can later though. Remind me, and I'll mention those pieces.
Also, if this PowerPoint can you give to us?
Absolutely.
So I can focus on.
Yes, absolutely. Well, Doctor, if I send something to Dr. Pippins, or Savvy, are you collecting information? Yes. If I send the PowerPoint to you? Yes. Okay. Okay, so I promised we would do our own investigation. We are going to investigate what factors determine whether something will float
จะได้รู้
or
ว่า
something will sink.
เขาพูดเกี่ยวกับอะไร
I'm going to give each group a cup that has different objects in it. You're going to see any number of different objects. Okay. I'm also going to give each group, this is your data sheet, your record sheet. You notice there's a spot that first asks, what do you think determines if something sinks or or floats. So as a group, I just want you to put down an idea. Then you're going to pick, let's say I pick up this object. I'm going to describe it, and then my group is going to decide, do I think this will sink or float? And then give us a reason, why do you think it will sink or float? And then we're going to save this last column. We're going to, after everybody has done predictions, we're going to test them out. So leave this one blank for now. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like room for 10 objects to try out to make predictions about. So, do you want to work in your same groups? Yes. Okay. Same groups. There's a good group.
That could be a small group because we have like.
That's true. That's true.
It could be more fun.
Oh, thank you.
นี่มันเกี่ยวเบ็ดน่าจะลอยอันนี้ก็ลอย
ให้ทำอะไรให้เดาว่าไหนจมไหนลอยเหรอ
ใช่
คะ
ครับ
แป๊บนึงนะขอเขียนนิดแป๊บนึงย้อนกลับไปเป็นเด็ก
จมทำหมดเลยดีเลย
แยกไว้
I think
ตอนนี้อัดอยู่ไหม
อัด
มันพอไปตลอดไหม
พ่อมา
แยกไหมอันไหนจมอันไหนลอยจมแน่นอนนี่ไม่จมนะ
เขาให้เดาก่อนใช่ไหม
เรา
เราเดายัง
นี่ไง
เดี๋ยวผมเขียนให้
อาจารย์ให้อะไรมาบ้างอันนี้เป็นสายใช่ไหมเป็นไปดูว่าอันไหนจมอันไหนลอย
พุดดิ้งจริง
ลงอันนี้ด้วยใช่ไหม
ๆใช่ครับ
Okay. Keep 5 things that you think is gonna. Keep 5 things that you think is gonna float.
เหมือนกันเลยอ่ะใกล้ๆแล้วมันไม่
I'm a student. I don't compare anything.
just object
อันนี้จม อันนี้จม อันนี้ลอย อันนี้ลอย
นี่เราเรียกว่าอะคริลิกป่ะ
เขาไม่ได้ให้บอกว่าเป็นอะไรบอกว่าให้อธิบายเอาแล้วก็บอกว่าแท่งใสแท่งกลมใสพลาสติกใสพลาสติกขุ่นตรงขุ่นสีขาว
ใสที่ว่าสะอาด
เนี่ยสีดำอย่างเงี้ย
อันนี้เป็น
กล
โล
ม
หะ
ใหญ่อันนี้จมอันนี้ลอย
You want another
8 already.
อู้หนักกว่า
ไหน
It would be
อันดำใช่ไหม
We want to compare this.
อันไหนดัก
พอๆกันเลย
อันนี้หนัก อันนี้ก็หนักจนไม่ขึ้นอันนี้ก็หนัก อันนี้มีดีอาจจะร้อน
ไหน
ไหมน้ำเยอะแค่ไหนเต็มแก้วนี่เหรอ
If you wanna do more observations.
บิ๊ก
ไม่รู้
มีบิ๊กดำบิ๊กขาวบิ๊กขุ่น
บิ๊กแบก
ที่จะบอกเนี่ยแล้วก็บิ๊กเยอะไปที่จะลองเขียนด้วยอันนี้บิ๊กน่าจะอยู่ด้วยกันเลยนะเพราะว่ามันจะไม่พอนะพี่มดดูดิของเยอะมีตาราง5 ช่อง
So we have to design the experiment that support this patient.
เราต้องคิดว่าเราเป็นเด็กโอเค
ที่เราไม่รู้เลย อันไหนอันนี้แล้วใส่นี่
คือเราแค่ให้วางว่าเปรียบเทียบ
อือฮึ
Okay.
อ๋อ
ที่เจ็บที่ไอ้ที่ไหนสมอง
อือฮึ
อย่างลบลบไม่มีอ่ะมันจะปากกาเนี่ย แล้วถ้าใส
This is heavier.
นี่เดี๋ยวเขียนใหม่ก็ได้นะหนูว่านี่เป็นบิ๊กไอ้นี่บิ๊กกันหรือเปล่าบิ๊กกับสมอลแบ็คอยู่ด้วยกันแบบไว้อยู่ด้วยกันดีไหมเขาไม่ได้เหรอต้องทำเดี๋ยวไม่เป็นไรไม่เป็นไรอันนี้เขียนเพื่อจะถ่ายรูปเฉยๆอ๋อที่จะ
เป็นอย่างนี้นี่เอง
ไอ้ที่ตกเบ็ดป่ะตัวถ่วงเขาเรียกอะไรนะ
ทุ่น
ทุ่นโอ้ยไอ้ที่ตัวถ่วงมันต้องตะกั่วเนาะทุ่นอันนี้เป็นทุ่นมีบูทด้วยนะบูทบิ๊กกับสมอลบูทสมมตินะสมมติว่าเราใส่ว่านะเราคิดอย่างนี้
เติมน้ำเลย
เฮฟวี่มันต้องไวค่ะนี่บอกว่าเฮฟวี่สุดเลยไปทำไมเอ็งถึงคิดว่าจะลอยเป้าล่ะลิฟต์ใช่ไหมอะไรเบาใช่ไหมนะ
ไลท์เวท
ไลท์ไลท์
เราเล่นหมดเลยเราเล่น10 คนเลย
อันนี้ไลท์
this one
เราไลท์เบส
ตัวนี้มันจะเปรียบเทียบได้
ขี่หรือเปล่ามีอีกไหม
ฮะ เจ๊ทำทุกอย่างเลยนะ
ไม่เพราะว่าเขาจะถ่ายรูปด้วยนะจะทำแบบให้มันดู
อ๋อ
จะถ่ายรูป
อ๋อโปรเจกต์แก
โปรเจกต์จริงๆอ่ะเห็นไหมบอกแล้วว่าถ้าหากเขียนไปอันนี้น่าจะได้พี่นกใช่ไหมไม่คิดไม่ออกกับเด็กๆไม่เอาตัวแบบเรื่องนั้นมาเดี๋ยวหาให้พี่มดจะได้ทำเร็วนะเดี๋ยวหาให้อะไรนะใช่ไหมมดมาเขียนเลยมาTHT เจอแล้วเหรอต่อไปแดนอะไรคะ
อันนี้ลอย
อ๋อ
พี่ปองระวังพี่ปอง
อะไรครับ
มันกำลังไล่คาถา
ขอโทษจะมีคาถาเหมือนกัน
ไร้ขนาดหาคู่อลูมิเนียม
ได้
อันนี้ก็ของจริงละอ่ะโอเคต่อ
โอเคนะ
จริงๆเราอาจจะไม่เขียนอย่างนี้ก็ได้
อือฮึ
เราจะขอยืมขอพวกเนี้ยยืมแล้วเราเรียงใหญ่อันนี้ก็ได้อันนี้เอาใหญ่ให้หมดเลย อันนี้หมายความว่าเราแบ่งเอาลบทำไมล่ะเอาใช้เลยพี่มดไม่ต้องลบหรอก
เอ้าไม่ลบอ่ะ
ก็แล้วแต่
อ๋อ
ถ้ากลัวมันไม่ชัดเราก็แบ่งตารางก็ได้เนาะใช่แบ่งตารางเป็นบิ๊กกับสมอลนะอยู่คนเดียวเลยมันชัดเหรอ
ไม่แล้วเรารู้ได้ไงว่ามันเป็นวัสดุเดียวกัน มันแค่สีเหมือนกันเฉย
ก็บอกแค่สีเราไม่ได้บอกว่าเป็นวัสดุ เราจะทำตารางให้มันแค่ว่าเอาตารางมากช่องขึ้นเฉย
ๆมันมีข้างหลัง
มันไม่เป็นไรนะสมออันนี้ก็สมอ
Yes, we're definitely happy about this.
แต่ว่าจะเขียนนี่ไม่พอหรือเปล่าวะไม่เป็นไรเราก็เขียนแค่ไลท์เฮฟวี่ มอแดงอย่างเงี้ยไลท์เฮฟวี่ไม่เป็นไรสักอย่างบิ๊กแอนด์เฮฟวี่อะไรอย่างเงี้ยเนี่ยต้องเป็นอะไรสักอย่างเราไม่ต้องเขียนแบบจริงต้องมีคำว่าความนุ่มอะไรเข้มข้นอะไรนะความหนาแน่นใครจะไปรู้ได้ไงไม่ดูวันจะบ้าเอาไม่เขียนแล้วเหรอเดี๋ยวเองอย่ารุนแรงสิพี่จะกลายเป็นว่าพี่จะไอ้นี่อ่ะไม่ใช่เดี๋ยวมันจะไม่ทันเอง
เป็นรูมเมทกันไม่ใช่เหรอ คุยกันรู้เรื่องนะ อยู่กันมาเดือนนึงแล้วนะ
อย่าเพิ่งรุนแรงไม่เป็นไรไม่ทันไม่บังคับอยากจะลอยแล้วนิวไม่ได้ลอยเลยเอาได้เลยนะทำได้เลยเพราะว่าเขียนนี่เดี๋ยวเราเข้าใจ
ยังเขายังไม่ให้ลอย
ไม่ให้ลอยเหรอ
ให้พีดีก่อน
ใจเย็นโอเคใจเย็นค่ะใจเย็นอันนี้อะไรนะนี่แล้วก็บิ๊กแบ็กก็ได้ละอันนี้อะไร
คาร์บอน
สมอลแบ็ก
อย่างเรื่องของที่สี่มันเป็นตัวตั้งว่าถ่ายว่าอะไรจะต้องถูกเธอต้องใช้ยา
เขียนร้อยนะ
ไว้ขอโทษบิ๊กคิดว่าเราเป็นเด็กคิดว่าเป็นเด็กใสด้วย
Are people done with predictions?
นั่นใสด้วยเคลียร์ transparent transparent เคลียร์ก็ได้นะเคลียร์ได้ EAR
Okay.
big
So I think everybody has predictions. Now that yes,
small
if you haven't done all of them, that's okay.
คือเขียนว่า
good
Oh, to the bottom.
down to the bottom.
มีอันเล็กไหมนี่ค่ะนี่ไงเข้ากันหมด
Okay, so everybody has made some predictions
Small wood.
about whether we think these
อ๋อเขาทำให้ดู
objects are going to sink, go to the bottom, or
อ๋อ
float.
เราไม่
เอาอันแรกค่ะ
Now that we have predictions,
metal เป็นวัตถุ
now here we
METAL
can have, does a brave volunteer want to come up and be our tester? Anyone? You want to be, okay. We have 2 brave volunteers, okay. Okay, let's see.
เดี๋ยวไปทำตัวให้นะพี่น้อง
Did anyone pick? Did anybody make a prediction about? You think it's going to float? Okay. How many people agree that this is going to float? Okay, so hold on to this for a second. Okay, I'm going to call that the large red and white bobber. This is it's a bobber, it's a fishing bobber. Have you seen it on a fishing line? So, okay. So I'm going to say the large, I think it's spelled, we predicted it was going to float, okay. Okay. Now we are going to put the bobber in the water and go for it. Yay! Okay. Now, like good scientists, we are going to test it a second time. Because what would, maybe he did something that influenced whether it sank or floated. So we're going to test it again. Yay, floated! Okay. Okay. So we can say, let's put our floating objects on this paper towel that you had. And we'll have our sinking objects over here. Okay. Would you like to test another object? Pick any object. Okay. They're picking these small bobbers. You think it's going to? You think it's going to float? How many people think the small bobber is going to float? Okay.
I think so.
Because it's a popper.
Do you know how many of my students say that? When I say, why do you think it will float? They say, because it's a bobber. Okay, let's do our test number 1. Float!
Hey!
Oh!
Just still float.
Perfect.
Okay. So far we have a large bobber and a small bobber. Now, one of the things I noticed about both of those objects, they're both round. I wonder if the shape of an object makes a difference. We'll find out, I think. Okay. How about you're going to try, that would be, we're going to call that the small clear cylinder.
Small clear ใส
Okay. Who made a prediction about the small clear cylinder?
Float I think float float
Oh, we've got this. Okay. Give it a
What
ผมคิดว่าจบอ้าวมันไม่ได้เป็นแก้วหรอกเหรอ ผมคิดว่าจบ
So we had a.
แต่ทุกคนคิดว่าเสียงดังกว่าเสียงทุกคนนี่ก็ได้
ทำไมไม่ได้ยินเสียงผม
ไม่รู้เรื่องเอาผมบอกอยู่ดีเสียงดัง
Now, just the second time.
จบ
ไม่เป็นไรค่ะอันนี้จบอันนี้จบอันนี้จบอันนี้จบหน้าจนปลาหน้าตก
ไม่เคยทำอยู่ว่าเป็นเสียงที่
เรื่องมันจะจบแล้วเมื่อกี้
ภายในที่ผมเรียนที่ดีอยู่เราเรียนที่ดี
Okay, what?
ก็เรียนชีวะใช่ไหม
I want to try food of food
What do you want to do this one first?
ชีวะสุดท้าย
Okay.
ไม่มีสิ่ง
So far we have 2 objects that have floated.
yeah
And we had the small clear cylinder. Now we're going to test
แล้วผมจะจบเหมือนกันเลย
the large.
large clear cylinder
And what do we think it's going to do?
float สิง
สองเหรียญ
I'm hearing both floating
สิง
and sinking.
sink
ผมพี่เอบอกจบ
How
สอง
many
เหรียญ
people think it's going to
ซิง
float?
สองเหรียญ
อ้าวเมื่อกี้ใครบอกโฟลต์น่ะใครคิดว่า
ผิด
พี่อาร์
ใครพูดผิด
ไม่ใช่กลุ่มเราเขียนว่าซิงจริงแต่เรา
สิงเออ
Okay. How many people think it's going to sink?
ปรากฏว่า
หมาปิ่น
Why do you think it's going to sink?
ก็คือ small one
ขนาดเล็กนี่ก็จมแล้วใหญ่จะไม่จมได้อย่างไร
Okay.
It's supposed to have the same
ปรากฏว่า
Let's see how it goes.
เย้
ไปออกไปเร็ว
Okay.
ติดตาดารา
And test number 2, what happened? Sink, okay.
ไม่ได้
So far we've tested 4 objects.
โปรเจกต์
You want to come up and
อันนี้
test
เหรอ
them?
โจม
Okay.
สีดำมันอ่ะ
What would you like to choose?
มูดเดียวมูดเล็กก่อน
That one?
small
อ้วนจะไปได้ไหมเนี่ยอ้วนลุกนี่อ้วนจะไป
ไม่ใช่ดูดิพี่พึ่งบางเนี่ย
พุงมัง
มองไม่เห็นนะพี่พึ่งบาง
Okay, we have a suggestion to test this is the small. Okay, so what do we think will happen with the
fruit
พี่พึ่งบางมองไม่เห็นนะ
I am hearing a lot of floating.
fruit
Okay.
Yes.
Why do you think it will float?
Light.
Oh, this is lightweight. Oh, it's lightweight. Why don't you test our small wood cylinder? Float! Okay, now a second test.
No, I don't count it. I count only I.
Okay, let's see if it floats again.
เย้
Okay, so far
บิ๊กบิ๊ก
we have two round objects. Both of them floated. We have three cylinder-shaped objects. You wanted to test? Yeah, let's do that and see what happens. What do we think?
large
Okay. We think float. Why do we think float?
The same material.
Same material. Lightweight, same material. Okay.
and
Let's test it,
light
see what happens.
Float on the river.
fruit too
Float, okay. We think, go ahead and test it.
1, 2, 3.
yay
Okay, like a good scientist, let's test it again.
จะให้บอกแต่กลางเขียน 1, 2, 3.
Yay! So you know what's interesting here? We tested a small and a large clear cylinder and a small and a large wood cylinder. So the thing that's the same about all four of those is the shape. Okay, now two of those things floated. What does this help us understand about the shape of the object? Does that determine whether it sinks or floats?
No.
And our evidence suggests that the shape of the object, in this case, doesn't determine sink or float. Oh, but now there's something, what's different about the small clear cylinder and the small wood cylinder? Well, yeah, and it's also the material they're made out of. Okay, so we have a couple of things. We're starting to see some patterns in the evidence that we collect, or the evidence we're generating. And remember when we talked about those features of inquiry, one of the things you are trying to do with students is to have them generate evidence to answer a question. Our question is about what determines whether an object sinks or floats. We're generating some evidence, and now we're starting to see some patterns to help us develop an explanation about sinking or floating. So we have some conjectures. So far we're thinking, based on this evidence, that the shape doesn't make a difference here. But material, right. So now we have some additional materials we could use to see if our pattern holds as we test other things. Okay. So, does anybody want to volunteer to be our next tester of objects? Okay. What would you like to test? The blue marble, okay. Now, do you think the blue marble will sink?
Sinks.
Okay, that sounds pretty definitive. Sink, okay. Go ahead and test it. Yay!
Yay!
Okay. hole in it. This one's interesting. Okay, wooden bead with hole.
ปีนเยอะนะเด็กปีนเยอะ
Okay, what do we think?
fruit
We think float? Okay. Go ahead. Okay. One more time. Okay, float. Okay. And can you do me a favor, and can we test this one? This one is a nut.
เอาแล้วไปหมุนใส่กันไว้ทำไมแล้วก็นึกว่าใส่ลงไปทั้งสองเลยน็อตนี่แยกเอาต่างหากใช่ไหมที่ใช้นี่เองเด็ก
ตอนแรกมาก็เอาไว้ด้วยกัน
อ้าวเนาะ
You think sink?
จริง yes
Okay, try it. Sink, okay. One more time. Sink. Okay. Thank you so much. All right. So I want to look at some of the patterns that we have in the evidence we have collected. Now based on our last evidence, we said, okay, I don't think it's the shape of the object. And we have more evidence of that after we tested the blue marble. Because we had the two bobbers, both of which were spheres, and we have the blue marble. So all three of those are the same shape. But now two of them floated, one of them did not. But they're made out of different things. You mentioned this before, I've heard. And now, we talked earlier about, we thought that the objects that were wooden, there was something about wood
อันนี้
that determined that
ไม่ควร
they're
เกิน
made.
ป .3
Okay, and now we have this wooden bead with a hole
ป .5
that also
ได้อยู่
confirmed that idea. Now the thing that's interesting, the reason I like this set of materials, if you are in 3rd grade and I'm asking you if you think an object is going to sink or float, one thing you might think is that something that has a hole will sink. And so what I like about this is because we have two objects that have holes, one of them floats, one of them sinks, it helps us think about this idea of, is it something with a hole that determines whether it sinks or floats? And we get evidence that, the hole does not make a difference. And if we continue to test the rest of the objects, you see we have left, is anybody curious about whether these sink or float? You think sink? Yes. Do we think this one is going to sink or float?
Sink.
Yes. Do we think this one is going to sink or float? Sink. Surprise!
Low density.
So now,
ไอ้ทึบพลาสติกทึบ
if we think that there's something about the material and not the shape and not the size, if the large black cylinder sunk, what's going to happen with the small black cylinder? It'll sink. Let's see. Well, what? It sunk. And now the large metal cylinder is sunk. Okay. Now this one.
fruit
Yay!
perfect
So again, as we look at this, what this set of materials helps us work on with kids is that it's not necessarily the size of the object, because we have big objects and small objects that sink, and we have big objects and small objects that float. Now again, think like a 3rd grader. You may think that something that's really big is going to sink. So that's why we're testing that it's not the size of the object. And I mentioned that something with a hole could sink, and so we can test it with this. But we started off with this question of what determines whether something sinks or floats, which is an investigable question. That would be one of our tenets of inquiry. We gathered evidence to answer that question, and then we started seeing some patterns in the information we collected. So if I were working with elementary kids, this is an example of what I would do to take them through a science investigation. The thing that's nice is it puts students in a very active role as a learner. And so the thing that I like about this is you were talking with one another and sharing ideas about if you thought something would sink or float. So what we do with students is we put them in a role where they're actively talking about their ideas. Okay, then you had an active role in helping with the investigation. I had you come up and share with everybody what your prediction was and share your reasoning. And then we tested it. And as a class, we came up with this chart. What I like about this chart is it gives all of us a reference point for making sense of the information. So you notice for the individual groups, I gave you a piece of paper that had some directions of what to collect. We used that as the first part of the investigation. And then we filled this in as our class, and so we can talk about our evidence as a whole. So those are some of the things I like to do is you give kids materials, you give them an active role, but then you have to have them share ideas. And then as a teacher, you have to help them make sense of the information that they're getting. And I think that is one of the really hard parts of inquiry, but it's where the teacher becomes most important. A friend of mine did something like, his students were doing something like this for maybe first graders. And he had a student that picked a set of objects where all orange objects floated. So the students who were doing an investigation like this came to the conclusion that all orange objects floated, which was just a coincidence on the objects you selected. But it became part of it. So they had to talk about how that was just, it's not that orange makes a difference, but it was that set of objects. So picking the materials you're going to use for investigation is also a very important role for the teacher. Like I said, I picked objects that have holes, objects that are different sizes, and objects that have similar shapes but do things differently, so you can test particular ideas. And I think that's key for doing inquiry. So yes, thank you for investigating with me. We're going to have, we'll see, maybe we're going to cut the video a little bit short. Now that we've done our own investigation, I wanted to take a few minutes, and we'll see how long we go through this. I wanted to show you an example of what inquiry looks like in an elementary classroom. And this is a video that was done several years ago. It's I think a third grade classroom, and they're investigating force and motion. Let me get that real quick.
ถ่ายรูปไปหน่อยครับเว็บนี้ถ่ายรูปไปหน่อยเนี่ยEdinburgh Learner
learner.org.gs ป่ะ org อะเซิร์ชเอา
and it's really nice to have you back with us today. We are off on a bit of an adventure to Cape Cod, Massachusetts. I'm sorry we can't take you to the beach today, but we are going to visit with Janet Smithers and her fourth graders in the town of Harwich, and they're in the beginning stages of an investigation into magnetism and electricity. And Sally, it sounds very different from other things we've been doing in this workshop series.
Right. I'm Sally Balunas, and Katie, you're so right. Magnetism does sound a little bit off the track, but we're going to be looking at the forces and not the larger issue of magnetism today. I'll help guide you through the physics revealed within today's lesson.
Breaking the force. Sally, we've been talking about forces acting on objects, and we're talking about the direction and the size of forces, but I think this is the first time that we've talked about breaking force.
Right, and today the students will be looking at the force of attraction between magnets,
Right.
and they'll be measuring the force of attraction changing as the separation between the magnets increases. Now, in our workshop series in the past, we have been looking at contact forces like friction or the push and pull on objects. But today we're going to explore a non-contact force, the magnetostatic force.
Okay, I think that once before, correct me if I'm wrong, we did come across a non-contact force, right?
We certainly did, Katie, and that is the force of gravity. The tug of the earth on an object, that's also a non-contact force.
And are there other non-contact forces that we need to be aware of?
Yeah, I can show you an example.
Okay.
Now, I know you have a balloon over there.
Yes,
Why don't you
I
get
do.
that out?
Okay.
And I'll show you. Now, rub the balloon on your sleeve. And then you're going to hold the balloon near, but without touching my hair. And then tell me what you see.
See some little tiny hairs trying to make their way over to touch the balloon.
Right.
Neat.
That's static electricity. And another non-contact force is electrostatic force that arises from static electricity. And the electrostatic force is defined as the force between electrically charged particles. Scientists usually think of four fundamental forces in nature. They are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. All the forces we see arise from these four. But some of them are very complicated, so we won't be able to explore them in depth in this workshop series.
Okay, but the magnets and the static electricity that we saw just a moment ago, those are both parts of the electromagnetic force, correct?
That's right, Katie, and we'll see yet another example of that in our next workshop series.
Okay, very good. Well, right now, our colleague Judith Peretz is standing by with teacher Janet Smithers at the Harwich Elementary School, and it looks as if the students are in their seats. So without further ado, let's get started.
Hi, Janet. Thank you so much for letting us join you today in this class. Tell me a little bit about what lessons that you have planned for today.
The lesson today, we'll be using the balances, and we will be breaking the force. And we'll be talking about the magnets and how they attract and repel. And we'll review a bit about the force of attraction, and we will measure the attraction.
I'd like to know how this lesson fits in the whole science unit. Is it the beginning, middle?
It is the beginning of the lesson, yes. It's part one of the science unit. And then we'll go on to electricity and then finally electromagnets.
Very good. What are the big concepts or the big ideas that you want to address today?
The idea we want to address today was we have talked about the force, and now we want to measure the force and to see exactly what we need to measure that force.
And how have you prepared the kids for today's lesson?
Just with the first lesson, and the first lesson was excellent. We found out what magnets stick to, attract, what they do not stick to, that we need iron objects, and we just walked around the room and used the magnets and to see what they would stick to. And then, of course, we had the mystery bags, and we were allowed to choose 3 objects to see what would stick and what would not. We made our predictions, and we're ready to go.
Sounds like it's going to be a lot of fun today. I'm going to watch outside. Good luck to you. I'll see you in a little while.
Thank you very much. That's that. Thanks. All right, let's start right now. Remember the other day, we had our pencils and our donut magnets. Place them on the pencils, place them 2 different ways. What was the mysterious something that we found out? What was that mysterious something? Yes, Jen?
Force.
Exactly. All right, now, today, we're going to talk about the force. We're going to talk about breaking the force. And we'll be using our familiar donut magnet, or some call it a ring magnet, and we'll be using the stationary magnet. All right, it's on a post. We just call it the magnet on a post. Watch the watch. Which force to break those 2 magnets that are attracting? They're sticking. Well, try.
The force of your arms.
I'm using the force from my arms, right? Am I using quite a bit of force? Using Adam?
You're using quite a little force because that's the force that brings them together. That attracts them is the force.
That's right. They're sticking. Now watch. Okay, same magnet on a post. Up here, again. Magnet on top. Take them apart. All right. How much force does it take? James?
Force on your arms to pull it apart.
Yes. Is it easy to pull apart, James?
It takes a little bit of power, but not much.
It takes a little power, not as much as maybe Hercules, but it does take quite a bit of power. All right. Now, what we're going to do today is use the balance tab to measure the force of attraction between the magnets. Can everyone see up that? If you can't see, please just go on the side. So we're going to take our magnet on a post and place it in the well. Make sure it's secure. It's in there very snugly. Then we'll take our balance beam. Be certain it's level. Jamie can tell us. Jamie, is it level? Yes. If it isn't level, okay, just in case, if you do get one, remember the slide. And if you move it just a bit, you'll be able to balance. You'll have it level. Okay. So we'll place it back on the fulcrum, right? Now, next, we'll place our cups. Still balancing. Now, watch this. We're going to take our donut magnet and carefully place it on the top of the magnet on the post. Now, we're going to break the force of attraction between these 2 magnets. We will use our washers. If you can't see, please come right up. You can sit on the floor right here. Everything. Place the washers into the cup. Everyone watching? Whoops. There we go. Now, what happened? It vanished.
It broke the force.
Absolutely broke the force. However, we need to be very certain. This is what I would like you to do. Back, so they are attracting again, and this will be our test. Now, the broken force, not